Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video, I will talk about CAIE 5070 past papers. Today, I will talk about paper 4 for specimen paper 4 for 2023 and onwards. First of all, let's look at the instructions for Cambridge O-Level paper 4, which will be followed for examination from 2023. It will be of 1 hour and instructions will be answer all the questions. Use a black or dark blue pen. You may use an HB for any diagrams or graphs. Write your name, center number, and candidate number in the boxes at the top of the page. Write your answer to each question in the space provided. Do not use an erasable pen or correction fluid. This is very important. You are not allowed to use correction fluid. Do not write on any barcodes. You may use a calculator. You should show all your working and use appropriate units. Information, the total mark for this paper is 40. Previously, it was 60, but now the total mark for this paper is 40. The number of marks for each question or part question is shown in brackets. Notes for use in qualitative analysis are provided in the question paper. This is something new. This is the qualitative analysis table. It will be provided to you. These are the tests for anions, tests for aqueous cations, and tests for gases, as well as flame tests for metal ions. Question number 1. Liquid Q is a fraction from petroleum containing large alkane molecules. Figure 1.1 shows the apparatus used to crack liquid Q. The vapor from liquid Q is passed over heated aluminum oxide to produce a mixture of hydrocarbons that includes alkenes. So here's figure 1.1. You see liquid Q on mineral wool. Heat is provided and there's aluminum oxide. Here we are having some empty boxes. We have delivery tube. We have mixture of hydrocarbons collected in the boiling tube. Identify the two pieces of apparatus by completing the boxes in figure 1.1. This is very easy. You can even write stand. Sorry, you can write stand or clamp. The next one is boiling or test tube used to collect gases. Boiling or test tube. State the purpose of the mineral wool. You can see here mineral wool is holding or absorbing this liquid Q. You will simply write to absorb. To hold, or you can even write contain liquid Q. Give a test and the result that shows the presence of an alkene. You know, alkene contains carbon-carbon double bond. And the common test we are having in our syllabus is bromine water. You can even write bromine in cyclohexane. Aqueous bromine or bromine in cyclohexane. Result is very easy. Turns from brown to colorless. Turns from brown to colorless. You can even write decolorized. State why the delivery tube must be removed from the water when the heating stops. You have to remove this delivery tube once the heating stops, because the reason is that it the test tube or boiling tube sucks back the water, and you may lose pushes back the water, and you may lose the gases obtained. So you will write to prevent suck back of water. Prevent suck back of water. Question number 2. A student investigates the reaction between aqueous sodium carbonate and two different solutions of dilute hydrochloric acid, labeled solution A and solution B. The equation for the reaction is given. Na2CO3 aqueous plus 2HCl aqueous. The product will be 2NaCl aqueous plus H2O liquid plus CO2 gas. You see, gas is produced in this reaction. The student follows the instructions for 3 experiments. Experiment 1. Use a volumetric pipette to add 25 centimeter cube of aqueous sodium carbonate to a conical flask. Add time of Thelen indicator. Fill a burette with solution A. Record the initial burette reading. Add solution A from the burette until the solution turns colorless. Record the final burette reading. A. Table 2.1 shows the student's results. Calculate the initial burette reading for experiment 1 and record it in table 2.1. This is table 2.1. Here's a table. Final burette reading is given, which is 13.2. Initial burette reading is missing, but the volume used is also given here, which is 13.2. So it's obvious you must be subtracting 0 from 13.2 in order to obtain volume used as 13.2. Experiment 2. Empty the conical flask and rinse it with distilled water. Repeat the method in experiment 1 with methyl orange indicator instead of time of Thelen indicator. Table 2.1 shows the initial and final burette readings for experiment 2. Initial reading for experiment 2 will be 12 point. Here's 12. 1, 2, 3, 4, 5, 6, 7, 8. So you write 12.8. What about final reading? Should be 39.2. Use figure 2.1 to complete table 2.2 for experiment 2. Here's a table 2.2. So final burette reading will be 39.2. And initial reading will be 12.8. So the volume used will be 26.4. You can add these two, 26.4 plus 12.8 to get the final burette reading. It should be 39.2, which confirms your answer is correct. C. Methyl orange indicator is red orange in acidic solutions and yellow in alkaline solutions. State the color change observed in the conical flask in experiment 2. So what was added in conical flask initially? You will write that color, whether the initial solution is acid or alkaline. It is alkaline initially, so you will write yellow here. We have sodium carbonate and acid is added. So in the end, we'll get the color due to excess of acid, which should be red or orange. Part D. Suggest one observation other than color change that is made when dilute hydrochloric acid reacts with aqueous sodium carbonate in experiment. It's very easy. Whenever metal reacts with metal carbonate reacts with acid, carbon dioxide is produced, and you can observe it through bubbling or fizzing. So you write bubbles, fizzing, or even you can write effervescence. Experiment 3. Empty the conical flask and rinse it with distilled water. Empty the burette. Repeat the method in experiment 1 with solution B instead of solution A. Use thermophthalene indicator. Table 2.3 shows the students' results for experiment 3. Here's the table 2.3. Final burette rating is 9.9. Initial burette rating is 16.5. Volume used is 6.6. E. Complete the sentence. Experiment dash uses the largest volume of dilute hydrochloric acid to change the color of the indicator. It's very easy. You should write experiment 2. Now state the effect on the volume solution B used in experiment 3 if the aqueous sodium carbonate is warmed before adding solution B. Give a reason for your answer. So there won't be any change in the volume because the concentration will not change. So you write none here. And the reason will be simply no change in concentration. Part G. 1. Calculate the simplest whole number ratio of volume of solution A used in experiment 1, volume to volume of solution B used in experiment 3. The answer must be in whole number. So it should be like 2:1. Part 2. Calculate the simplest whole number ratio of concentration of solution A to concentration of solution B. It's very easy. 1:2. H. The burette is emptied and reused in experiment 3. Suggest an additional step after emptying the burette which would improve the accuracy of the results. In order to get more accurate result, you will rinse burette with solution B. Rinse burette with solution B. 1. Titrations often give inaccurate results if done only once. Suggest how repeating each experiment several times produces more accurate values. So you're repeating until you're getting similar results. Then we will calculate the mean of similar results. So repeat until similar results obtained. Repeat until similar results obtained. Calculate mean. Of similar results. Question number 3 is, the student tests two solids, solid C and solid D. Test on solid C. Table 3.1 shows the results and the student's observations for solid C. Here's table 3.1. Appearance, green solid. Test 1, heat. We get the solid turns black. Test 2, at dilute sulfuric acid, you'll see rapid effervescence. Test the gas produced, lime water turns milky. Test 3, to the solution produced in test 2, add aqueous ammonia dropwise and then in excess. A light blue precipitate forms which dissolves form a dark blue solution. For this question, you will refer to the qualitative analysis. For example, we are passing the gas when it's produced after reacting with acid and it's turning lime water milky. So what must be the gas? It's the carbon dioxide gas, and as it's turning lime water milky. The other thing, for the cations with aqueous ammonia, we are getting blue PPT, which is of copper 2 plus. A. Test 1 states that the solid is heated. Suggests why it is necessary to heat gently at first. You have to heat gently at first. The reason is that you are heating it in the tube, so the tube might crack. The tube might crack. Also, there's a chance that solid might spits out of the tube. So you write solid spits out of the tube. Solid spits out of the tube. B. Describe how you would use lime water to test the gas produced in test tube. Now they are asking about the procedure. It's very simple. You can either use pipette or delivery tube first. Delivery tube or pipette. Then what you will do, you will pass the gas through lime water. The bubbles will be obtained. You pass the bubbles or gas through the lime water. Pass the bubbles or gas through lime water. In second test tube, you will perform this. So you have to write in second test tube. C. Identify the gas produced in test tube. Now you have to identify the gas. This is very easy. You can either write the formula of the gas, which is CO2, or you can write the name of the gas, which is carbon dioxide. Now they are asking about the identity of solid C in part D. It's very easy. It must contain copper or Cu2 plus, copper or Cu plus 2 or 2 plus, both are correct, and carbonate or CO3 2 minus. Carbonate or CO3 2 minus. You can even write copper carbonate. Copper carbonate. Test on solid D. Solid D is potassium iodide. The student makes an aqueous solution D, using solid D and divides it into two portions. E. To the first portion of the solution D, student adds an excess of aqueous sodium hydroxide. Complete the expected observations. Now they are talking about the observation. We don't have any test for potassium ion in our syllabus, so you write no change or no reaction. Part F, the student tests the second portion of solution D to show the presence of iodide ions. Give the test and the result that shows the presence of iodide ions. Again, you will go to the qualitative analysis for the testing of anions, and here it is iodide ions. First of all, you acidify with dilute nitric acid, then add aqueous silver nitrate. You will get yellow PPT. So what we will write here, you will write dilute nitric acid. And aqueous silver nitrate. Result, yellow PPT or precipitate. PPT or precipitate. Part G, the student does a flame test on solid D. Complete the expected observations. Observations. what will be the observations? So the flame test should be of potassium. You see the salt is of potassium iodide. Look at the color for potassium. It's in the flame test. The color will be lilac, potassium K plus. So you write lilac here. H, describe how to do a flame test. So you can write any three from these. We'll use clean wire with solid sample. Use clean wire with solid sample. Then we'll heat it with hot flame. Or put wire spring into flame. Put wire into flame. Last one, you'll observe and record the flame color. Observe and record the flame color. Last question. Question number 4. Plant leaves contain a mixture of colored substances. Plan an experiment to find the RF values of the colored substances present in plant leaves. Your plan should describe the use of common laboratory apparatus, plant leaves, sand, ethanol as a solvent, and absorbent paper. You may draw a diagram to help answer the question. So this one is an option for you. If you want, you can draw the diagram. Look at the question. They have already told you that the technique is chromatography, because here we are having colored substances. So colored substances are separated or identified through chromatography. So if you're writing the answer, so you can write this statement. You can write any 6 of these. I'm writing the easiest one for you people. So you write chromatography. It must be here. You'll get 1 mark for this. Then you will, what you will write? You are using chromatography paper, so you have to draw a line in pencil. Draw a line in pencil near the bottom of the paper. Two marks. Next point, then you write apply extract to paper. Apply extract to paper. I will talk about this, how you will obtain the extract in this experiment. Place paper in solvent. Place this paper in solvent. Then allow the solvent to travel up the paper. Allow the solvent to travel up the paper. Then mark the solvent front. Mark the solvent front. Then you will obtain the RF value. So you have to write how you will obtain the RF value. RF can be obtained by dividing the distance traveled by the substance. Distance traveled by the substance divided by distance traveled by solvent. Distance traveled by the solvent. Now I will talk about how you will obtain this extract. You can write grind or crush plant leaves. Grind or crush plant leaves. They have mentioned ethanol and sand in the question. So you write using mortar and pestle with ethanol and sand. Then last point, can filter liquid. If you want to draw the diagram, you can draw the diagram for chromatography, paper, and everything. Thanks for watching. Press like and share my videos. For more videos, subscribe the channel and press the bell icon.